Hello. In this video I'm going to show you how to use a piece of software on a particular website to visualize a solid revolution. In calculus, we often want to find the area, or rather volume, of a solid revolution, but I think it's difficult to visualize what exactly we're finding and why when we change certain factors, the volume changes. So I did find this website that I think does a pretty good job of quickly generating a solid revolution, and I think it's a good way of visualizing how this looks. First of all, let's look at a problem. So let's consider a problem like this. Let's say we were asked to find the volume of revolution, find the volume of revolution created when the area bounded by, I'm going to always have two curves usually. I shouldn't say always, we usually have two curves. Let's give these two curves in this case are going to be y equals 4 minus x squared, which is a parabola facing downward, opening downward I should say, and y equals x squared plus 2, which is a parabola facing upward. Okay? And that's a simple flat two-dimensional area, I should say. That's a two-dimensional area that's bounded by those two curves. But we could rotate that area, and again, the point of visualizing in the software is to see exactly what it means to create that volume of revolution. And I think that's a difficult thing to see, which is why students might struggle with understanding exactly what we're doing. Okay, so these two curves will intersect at 2 points. They're two parabolas. One's opening upwards, one opening downwards. And we can rotate it a variety of ways. We're going to rotate it around two different lines. First, we're going to rotate it around the x-axis. And we're going to rotate it around an arbitrary line. In this case, we're going to say around the line y equals -3. Okay. Now, I'm not going to go ahead and process through exactly how we find the specific area. That's not the point of this. The point of this is to show how to use a specific piece of a specific website to visualize it. And to visualize this, we're going to go to this website here. Let me increase the font on that. We're going to go to this particular website to do that. Before we go there, though, let's look at how these look in Desmos. So this is 4 minus x squared, and this is x squared plus 2. We can see it in Desmos. We can see that it does have these two intersection points. We're going to take this area right here, the area in the Desmos. Let's go ahead and shade that in so we know exactly what we're talking about. We're going to take this area right here. When we're talking about shading, we're talking about this area right here. And when we're rotating it around a particular line, we're talking about taking this thing and rotating it around. That's going to create a donut shape, but the volume of that donut is going to depend on how far it is from that line. For instance, if we simply rotated around the line y equals +2, which is this line right here, it would create not really a donut so much as a more of a ball shape. Still kind of donut shape, but a donut without any real hole, just an impression like that. And if we rotated around the x-axis, which is down here, then it would wind up with a more solid donut shape. If we took this line and we moved it up and down, it would change the shape of this donut. Now, this is all very difficult, I think, to visualize on a 2D shape, a 2D environment. Instead, what we're going to do is we're going to go to this Shodor.org website, and we're going to visualize it in 3D. Now, There is some kind of flaky thing. This website is more organized, I think, towards a tech savvy, geeky sort of mentality, and so it might be a little bit more difficult for somebody looking at this to try to figure out exactly what's going on. But the first thing we do is we're going to put in our two functions. So we've got y equals 4 minus x squared. We have x squared plus 2. And again, what are we going to do? Let's set the functions there. We notice we're going to talk about this little area. Now, this far off, we're not going to want these chunks here. If it rotates, it's going to be a complete and total mess. Let's see what happens if we don't do anything at all. Yeah, we get that, which is total garbage. Okay, that looks like a complete mess. We don't want this. So instead, what we're going to do is we're going to want to go ahead and set our parameters. Go ahead and set our parameters so that we only look at this one little shape here that's in the middle here. We just want this. Now, what are these two spots? Well, we need to calculate what those two spots are. And if you've not already done so, the way you would do that is you want to find the points of intersection of these two lines. That's going to be 4 minus x squared equals x squared plus 2. We have an x squared on both sides. We have a constant on both sides. We want to rearrange those. When we rearrange those, we're going to get 2x squared equals 2. That leads us to x squared equals 1, or x equals plus or minus 1. Those are our points of intersection here and here. And as you can see, Desmos already showed us that those are our points of intersection. So let's go ahead and set here. This is going to set our points of intersection, -1 to 1. Okay, we set the function, and we see that, yes, indeed, that is now just that one single thing. If we revolve it, we're going to revolve it around the x-axis. We'll talk about that in a second. But if we revolve it, we're going to see just that section rotated around. Now, we could go ahead and just revolve it. However, I think this is a little small. It would be nice if we can zoom in a little bit, and we can zoom in a little bit. We go over here to set window. We can go ahead and zoom that in. Let's say we want to go from -5 to 5 instead of -15 to 15. And when we do that, we'll see it zooms in a little bit, and we can see it a little bit easier. So let's go ahead and revolve that. And this is what our solid revolution looks like. Okay, notice if we don't like these colors, notice that we've got some options here. It says that function 1, which is the 4 minus x squared, is going to be in blue. That the second function is going to be in green, and we see that's exactly what it is. We get this tire or donut shape, and the software will let you look at it, rotate it around, see exactly what's going on here. Okay? And this is where we've rotated it around the x-axis. So this is, it says a line y equals 0 equals the x-axis. This is what happens when we rotate it around the x-axis. If instead what we want to do, though, notice I press the set functions again. This will keep us here, so we can go ahead and start over with this fresh. Now, let's say we wanted to rotate around a different line. So we're going to rotate around y equals -3. When we rotate it around y equals -3, notice that it puts in a purple line to tell us that we're now rotating around this line, and we see that it's a much bigger shape now. Looks more like a bicycle tire than it did before. It looks like a donut perhaps before. And again, this is a visualization. Notice there are these straight lines here. That's not really the case. These would be smooth curves if this were the actual shape. This is because of the nature of the software that's using this here. But regardless, this is a nice little way of showing it how it rotates. Okay, finally, let's look at that one other case where we rotate exactly around the intermediate line, and we get this still sort of donut shape, but it's not really. It's more like a disc with an indentation on it. We could even, if we wanted to, for that matter, rotate it around, say, 2.5, which is right here. It's not going to even be a full axe. It's not even going to be a fully donut shape. It's going to be a weird overlap thing. And we see what happens there. We still have a little tiny indentation. We have even more of a disc, and so on. In fact, if we rotated it exactly around 3, because these two are symmetrical, we're just going to wind up with a very simple, I shouldn't say simple perhaps, but somewhat boring shape there. Okay. So that's the general idea on how to use the software for visualizing. Again, this doesn't find the volume specifically. It does find the volume. I'm sorry. Okay, over here it does find the volume. So let's go back here though. So set functions. Always set the functions. If you press clear graph, if you press the clear graph button over here, it will erase these two functions. So you don't want to do that. You want to press the set functions to reset everything. And then let's go back to the x-axis. That's y equals 0. Let's revolve around that. And you see when it does that, once it's done revolving, you will find the volume, which is approximately, these are approximate 50.26. And these particular numbers, by the way, this leads to, I believe it's twice the volume. I might be wrong. Exactly twice the volume. So 100.521 is exactly twice the volume. By rotating around this lower line here. Okay, so that's the general idea on how to use this particular site to visualize what's going on with these solids of revolution.